So in that last video, we looked at how, let me just go to it real quick, how we were able to basically just grade an pathway onto an existing landform and utilize the existing topography to kind of dictate the slope of the pathway. However, as we noted, there are some major constraints, such as these red and pink areas, which denote that it's exceeds that ADA accessible constraint of 0 to 5% without landings. So what we want to do now is look at how can we um, reproject essentially our path or remap it to basically turn all of these points into this blue tone. And so that's what this script is going to do. You can start to see in this case, I'm still using this other color tone. So 0 to 5 is from green to yellow. And so you can see that now it's that same pathway, but now it's all graded nice and flat. Obviously, again, that's going to create some major alterations to your landform. You can see that there's some major kind of landforms that get extruded up to allow for it to not have to go too steep down. And then same thing with areas where it gets really steep, it starts to cut away. That again now becomes part of your uh, design decision making of what you're going to do. Do you alter the path so it doesn't cut away? Do you add a retaining wall to allow for that to still occur in order to maintain it? Grasshopper isn't going to give you all the answers, but it is at least going to give you some working constraints. So now we're going to look at how we can quite literally adapt this previous script here and get it to match these conditions. So I would recommend, if you haven't already, to use the previous script, and that way you can easily just kind of build from it, because again, it is a little bit of a process to do and there's no reason to have to repeat yourself. So what I am going to do is literally start from that previous script here, and I'll show you where you need to kind of replace some things. So I'll keep my surface here, but I'll also begin to move some of these things around. I do want to note that this is the existing pathway that got projected onto our surface. So we do want to remember which ones are going into our new side slope grading part. So I'm going to go ahead and I guess I don't really have to worry about that one, but I do want to make sure. I mean, let's just double check. So that one has 144 points. It should still give me, well, there's 143, but I know the workaround. So I'm not worried about having to remember to replace that one. But let's just do it anyways, just to be safe. So I'm going to do Control G to highlight that. It's also going into that, so I'll highlight that because that is going to be really important, as well as this one over here. So I'll remember to get these things replaced. So I'm going to go ahead and lock this for now. So that way I can disconnect the link to those components. And now I can shift all of this plus this, because I'm not going to need it till I get to the end of my script. So that's like that original for the length. So I'm just going to replace that one into there. So that way I can move this over to here, and it's probably going to need to get situated over here. Okay, and I'll kind of tighten this up too. So let's just go ahead and do some of this. Let's just move some of these things a little bit closer. This part is again gonna go off to the side because we're really just gonna work from here. Because again, it's the same process to find out those calculations, but now we're basically gonna figure out some of those constraints. So there's a couple ways of doing this. So I've got my slope here now, right? So here's my percentage. I'm not worried about the absolute because I still want to make sure I maintain whether it's a positive or a negative slope, or whether it's going downhill, starting from over here, or if it's coming uphill over here. That's still important. So I don't want to include that absolute component. So there's a couple ways you can do this, and I do want to show both options. You can think of how do you regrade this entire pathway to kind of adjust. So kind of thinking about if I were to turn off my contours here, if I were to look at it like this, where I can kind of see what that slope is of the overall path, imagine kind of starting to remap it or shrink it or make it a little less steep. So you're kind of just taking all the high bounds and the low bounds and just kind of uh, remapping them that way. The other way is that you can think of, okay, you know what, I do want to maintain the ones that are within that 0 to 5%, but everything that exceeds that, I want to make sure that um, those get capped at a certain slope percent. So what I can do is show both of those options for you. So the first one, like I said, is you're basically just remapping those. So I'm going to take these slope percentages. I'm going to find their bounds, right? So we can see that there's some areas that are going down negative 17% and other areas that are going up almost 18%. So we want to make sure that we, again, set those constraints in both directions. So I am going to construct a domain, and I want to make sure that I use both the same values for either. So I'm going to just do something between, let's say, again, and these are still in decimal format, so I'm going to do 0.03 less than 0.08. Again, we do want to kind of stick to that 5%, but this just kind of shows you if you do give it some variation. So I'm going to use B as my positive slope. I'm going to right click here to give it an expression and make it negative x. So that way I'm now basically remapping that negative 17 and positive 18 to negative 5 and positive 5% slope. So that's basically what that does. So I'll actually kind of move forward before I show you the other technique, just to kind of show you that progression. So now that I've got, again, my kind of consecutive slope percentages, right? So I'm going from here to the next one. I do need to actually accumulate them now. So I'm going to use that same approach as before, where I find the consecutive domains. And in this case, I am going to keep this true. And let me just show you why you would want to do that. So again, if I were to draw this and imagine that it's going up from this point, oops. So if I were to imagine it going from this point to this point, oh, it is not liking this, to this point, to this point, and let's say this one's 2%, this one's 7%. I don't want to keep these separate of kind of keeping them as this is 2 and this is 7. I actually want them to start to add up, because this one should be, again, this one will stay the same. The next one will be actually 9%. If this one then goes up 3%, then this becomes 12%. So if you were to kind of think of those kind of bounds, that's why we do want these to actually accumulate, because they are an additional process. So let's go ahead and get rid of those now. So I am going to keep it that way. And you'll see that, again, I get those values. And again, I need to now deconstruct these so that I, again, use the correct one. So I want to make sure that again, as I see these, it's 0.27 to 0.23, which then get it out up to 0.27, 0.49. So we want to make sure that we still use the starting one in that case. So 0.27 to 0.49. But we also want to make sure, you can see that the very last one goes from 0.267 to 0.275. If I were to just use this, you're going to see that we're going to lose one. And you can kind of see at the top it says 142 versus these very first one we have 143. So we do want to make sure that we also include that very last one. If you were to do it this direction, then you'll see that then we're missing that first one. So it gets a little bit tricky, but again, it's not that challenging. So I'm going to go to Sets, Tree, and Merge. So I want to start off by just using all of these start domains. And I just want the very last one of this one. So 0.275, because it's not included there. It ends at 0.267. So I'm going to do a list item, drag that into there. And I'm going to actually, let's try this. I'm going to just reverse this. And that should give me that very last one in this case. So now I can grab that. And now you'll see that we go back to our 143 values that are coming out of here. You'll see though, out of all the points total, we actually have 144. That's because we don't have a slope for this very first one, right? But we still want to make sure that we include that. So what I also want to do is, again, I'm going to, now that I have the slope, I want to, again, kind of, the way this is working is that we're moving these points in the vertical direction. So let me just make some more room for ourselves. Again, I might just have to move this part a little bit more once again. We're close there, so it's no big deal. But again, so this is slope percentage, but we need to actually convert it back to moving these points in the vertical direction. So again, we use that equation of length times slope will give us distance and elevation. So we're going to take the math and we're going to multiply, again, our slope values. That's what all is coming out of here. And we're going to multiply by the length, which is, again, just 1 feet. So it's literally just going to give us the same values, but again, in case we use a different distance of something other than 1, we want to make sure that that gets calculated correctly. So now that I have our distance and elevation, now I can actually add that 0 distance and elevation too, which is our very first point. It's not going to move. We're just going to keep that there. So again, we want to do sets, tree, merge. And so we're going to use this as our D2. We're going to use 0 as our first one. And so now we have all our new, and we just want to go ahead and flatten that because for some reason it's a different branch. And so this is going to give us our new move values in the Z direction. So again, I'm going to use move. These are the points I'm moving. And again, I'm just moving these in the Z direction. And you'll see now that, again, it's remapped them entirely. Oh, that's not right. Oh, that's right. I forgot to do one last thing. So I'm not actually moving these ones. I do want to project these down onto its original plane. So I'm going to do, I want to project them onto whatever that very first point is. right? So now they're all technically on that, and now it'll stick within that constraints, because earlier is still kind of utilizing the previous slope or in the point location. So we actually want to start from scratch, essentially. And now you'll see, there we go. Um, that's where our new point is. And so you can see that it's a much more gradual slope. It's not perfectly flat, so don't think that. You can see that there are those some areas where there's some slight uh, change in direction. So if I even go in your front, you can see that again, 5% isn't significant. So that's where these areas that are really steep have the most significant change. So that's what I was saying, where there are going to be some areas that's going to require you to add a lot of earth to kind of allow for that vertical movement. But from here, before I start plugging these back into the original, I'll show you that other technique. So instead of just remapping them or just scaling their slope, we can, like I said, cap these as well. So what I want to do is, again, I'm going to take these values, going to go to math, and so I want to return the greater of two items. So in this case, we're going to start off with, I'll drag that into there. I still want to use the same parameter, so I'll do negative value of 0.5. So anything that goes above or greater than 5% the negative direction, it'll cap it there. And vice versa, I want to return any value that exceeds 5%. So you can see that, for example, it starts off, so 0.096, 0.083. Now those are all going to get capped at 0.5. So anything that goes that, so imagine, again, I'll draw this real quick. If this is your slope and like all of these areas are exceeding that 5%, it's essentially going to take it, I guess that would probably be much gradual, and it's just going to make it perfectly straight and then kind of return it. So, I mean, it's not exactly the most ideal in some cases, but it still does achieve that outcome. And all you have to do is now replace that one into there, and you'll see that, yeah, those values that exceed that basically turn out to be perfectly straight. I guess they aren't. There's still some variation to it, but for the most part, they do get capped. Yep, that looks good. So let's just keep moving forward. I honestly prefer this one. That way it still kind of maintains some slope instead of just kind of keeping them all the same, but you can keep those for that. And now we can do the same thing. We can actually begin to determine if that does in fact correct our slope. So we're going to use the same thing. We're going to use our remapped values. Now I can turn this off. Oops, actually in the geometry we want to use is this new geometry. And now you can see that everything's kind of within that blue tone. So again, it's not a huge kind of steep condition. It is going to stick within that 5%, which isn't a whole lot, but it does give us that ADA accessibility. So now again, we can now apply that to that existing one so everything gets done correctly. So I'll again lock this because it's going to process a lot of things. So I'm going to plug that into there, plug it into that one, and I'll plug it into this one. So everything that I highlighted goes back to the same. And now I can go ahead and unlock it. It'll take a second. And now I'll go ahead and turn my contours back on. And now you can see the pathway is now nice and on grade. Still maintains that 0 to 5%, but you can see that it does start to alter your landform a little bit more than the last one, right? So now we have more of this kind of berm that allows for the pathway in that low point, and then there's this cutout in that hill area for that part. So you have to make that decision. Do you allow for that cutout to still occur, or do you start to alter your pathway to not obstruct that? And you could always kind of just manually, you can kind of see like, okay, where is there not a lot of slope change? Like it makes sense to maybe like kind of take that there. So let's just give that a shot real quick. I'm going to turn off this contour and disable it because it is a lot of processing power. And I will turn on my surface so I can at least try to remember where that occurred. So I'll turn on show so I can see that pathway again. I'm going to turn the points on. I'll go to my top view, and I will kind of have it do something maybe more like that. And so let's see how that affects our landform, if it's as invasive. So let's take a look. So again, it kind of takes away from that side, but it does protect that one. So again, there are some trade-offs in either direction. What's interesting as well is that maybe there are some ways to avoid some of these conditions, right? So in this case, maybe I don't have to have this berm cut across. Whenever it maybe starts to exceed a certain elevation change, right? If I look at the original points, let's show those ones real quick. Maybe as soon as the original points start to go down, you can start to say, you know what, like maybe I don't want to use the berm, I could use a boardwalk instead. So that way you can still allow for drainage to happen underneath instead of kind of dividing it out. So that's what the next video will show, again, kind of building off of this, but replacing some of these areas where there's a lot of this kind of extruded landforms in the upward direction and replacing that with something such as a boardwalk. So keep an eye out for that one.